After studying this module, you shall be able to know about the significance of designer drugs, classification of designer drugs, and the forensic analysis of designer drugs. Over ages, humans fortunately discovered that certain ingested plants were a source of unique satisfying feeling beyond satiety. Some were mildly affecting, example nicotine and caffeine. Others enhanced mood or altered perception, reduced pain, intoxicated or produced euphoria, example alcohol, marijuana, hallucinogens, opiates, and cocaine. In the past 2 centuries, consumption of these psychoactive substances expanded rapidly. Decontamination of the active chemicals, distribution by maneuvers for maximum effects, and global marketing contributed to this expansion. Modern chemistry has produced a huge range of variation of these plant products, paralleled by an unprecedented level of adverse biological, behavioral, medical, and social consequences. Following this phenomena, designer drugs are produced to be similar to but not identical with psychoactive drugs that are illegal to possess or sell for human consumption, unless for medical purposes. A recurring threat to public health, the designer drug subculture has burst out over the past decade. The rapid expansion can be attributed to a convergence of crucial technological advances combined with deceitful, aggressive marketing schemes. Forensic issues. Designer drugs are produced in laboratories, the majority resembling drugs legally restricted for distribution and possession. They share one common trait, producing psychoactive effects that can range from cannabis-like psychomotor stimulation, dissociative anesthesia, to hallucinogenic. Examples include mephedrone, methylone, MDPV, ethylphenidate, synthetic cannabinoids in spice or K2, 2,5-dimethoxy-4N-propylphenethylamine 2CP, N-adamentyl-1-pentyl-indole 3-carboxyamide 2-NE1, methylpropionamine, and methoxytamine. They are retailed economically as bulk powders and are deceptively labeled as research chemicals, bath salts, plant food, incense food, or by other names and labeled as not for human consumption. The designer drug industry is a niche business with a simple strategy to circumvent existing drug laws and endorse their products as legal, create new markets with rapid profits, undercut producers and prices of common illegal drugs, and undermine routine clinical drug testing. The consumers misinterpret the drugs as legal, less hazardous than conventional street drugs, and more intriguing. They are more challenging to detect and easier to evade routine clinical drug testing. Standard strip tests do not identify most of these compounds. Nonetheless, most drugs or their metabolites are effortlessly isolated from biological samples, including hair samples, and can be identified in laboratories with standard or advanced analytical techniques. Designer drugs may evoke psychoactive effects similar to the parent drug or stimulate a more intense, amplified, unique or life-threatening response. Occasionally, new drugs are designed or discovered that have neither precedent in medicinal chemistry nor a long history of abuse. Example, salvinorin A, yet they may possess equal or greater abuse potential or health hazards. Drug traffickers bypassed drug laws by developing analogs of banned opioids as early as the 1920s. During the 1960s, a rash of new psychoactive drugs were introduced to the world. The resistance to drugs and a shift in perceptions took years to penetrate public opinion. When drug use became viewed as reducing natural potential and the consequences of drugs in family members, schools, and the workplace began to take a toll. Classification of designer drugs. Current designer drugs can be classified by their chemical structure, by their psychoactive properties, by their known biological targets, or by their source like plant, synthetic, or combined. First is cathinones designer drugs. The drugs most found in the bath salts are substituted cathinones, synthetic derivatives of the stimulant chemical in khat. Bath salts are disguised as plant foods, insect repellent, stain removers, and sold under brand names such as Bliss, Blue Silk, Cloud9, Drone, Energy One, Ivory Wave, Lunar Wave, Meow Meow, Ocean Burst, Pure Ivory, Purple Wave, Red Dove, Snow Leopard, Stardust, Vanilla Sky, White Dove, White Night, and White Lightning. The products are sold as powders in small plastic or foil packages of 200 and 500 milligrams. The structure of phenethylamine, a trace amine found in the brain, is the backbone for most of the stimulant-type designer drugs. These compounds are easy to prepare and can be chemically molded in a myriad of ways to produce stimulants. Amphetamine, stimulant like hallucinogens or entectogens. Cocaine and amphetamine like psychostimulant drugs. Mephedrone, methylone, and pyrovalerone analogues, including MDPV and nephedrone, are some of the chemicals packaged as bath salts. Second is cannabinoid designer drugs. There are three types of cannabinoids designer drugs. First is phytocannabinoids. These are produced by plants. The marijuana plant produces over 70 phytocannabinoids. Tetrahydrocannabinol or THC is found at much higher concentrations than any other cannabinoid in the common Cannabis sativa plant, one of the several plants that produce cannabinoids. Second is endocannabinoids. These are produced by the brain and other organs. The body produces 7 or more endocannabinoids, 2 of which are widely distributed and function in cannabinoid signaling: anandamide, 2-ara-kidonyl ethanolamide, and 2-AG, that is 2-ara-kidonyl glycerol, which resemble but are not identical to cannabinoids of plant origin. Third is synthetic cannabinoids. These are developed over the last 30 years as research tools to explore cannabinoid symptoms in the brain and other organs, and to discover the feasibility of developing cannabinoid medications. Cannabinoid communication or signaling system has 3 major components. First, a chemical message or neurotransmitter, example, endocannabinoids. Second, a receptor that interprets the message. Third, an enzyme that degrades the message. All designer cannabinoids mimic the psychoactive effects of marijuana, with some considerably more potent than marijuana. Their metabolites may differ biologically from marijuana. Group is hallucinogens designer drugs. A number of hallucinogens and other psychoactive drugs are evolved into street drugs. First, phenethylamine, analogous to mescaline. Rigid equivalents of phenethylamines and benzyl phenethylamines, example 2C-B-fly, BR-fly, and BR-dragonfly. Salvinorin A, tryptamines, and dissociative anesthetics methoxytamine, ketamine, and PCP. Phenethylamine derivative potencies, example amphetamines, mescaline, have been increased by locking the structure more rigidly to produce compounds designated as fly. Some are exceptionally potent, and one BR dragonfly is related with an overdose death. DMAA, that is 1,3-dimethylamine, is a common ingredient in party pills. Some notable designer drugs. First is methamphetamine. Methamphetamine is a powerful addictive stimulant that vividly affects the central nervous system. The drug is prepared easily in clandestine laboratories with moderately economical over-the-counter ingredients. These factors combine to make methamphetamine a drug with high potential for widespread abuse. Methamphetamine is commonly known as speed, meth, and chalk. In its smoked form, it is often referred to as ice, crystal, crank, and glass. It is a white, odorless, bitter-tasting crystalline powder that easily dissolves in water or alcohol. The drug was developed early in this century from its parent drug, amphetamine, and was used originally in nasal decongestants and bronchial inhalers. Methamphetamine's chemical structure is similar to that of amphetamine, but it has more distinct effects on the central nervous system. Like methamphetamine, it causes increased activity, decreased appetite, and a general sense of well-being. As a central nervous system stimulant, methamphetamine directly affects the brain and the spinal cord by interfering with the formal release and uptake of neurotransmitters, chemicals that nerve and brain cells produce to communicate with each other. Dopamine is the primary neurotransmitter affected by methamphetamine, but norepinephrine and epinephrine are also affected. Second is methylenedioxymethamphetamine, that is MDMA. Methylenedioxymethamphetamine, MDMA, or ecstasy, is a synthetic drug that has found widespread use in young adult populations. The compound MDMA was first synthesized in 1914 and originally developed as an appetite suppressant. However, the compound was never used for that purpose, and in the 1970s, recreational drug use with MDMA was first noted. MDMA is an amphetamine derivative. Ecstasy causes release of neuroactive compounds such as serotonin, 5-hydroxytryptamine, dopamine, and norepinephrine into the central nervous system. Additionally, neural uptake of these neurotransmitters, most notably with serotonin, is inhibited by ecstasy. These actions result from the interaction of MDMA with the membrane transporters that are involved in neurotransmitter reuptake and vesicular storage systems. The net result of these central nervous system effects is to increase acutely the levels of these neurotransmitters at the synapse. These effects of neurotransmitter levels lead to many of the effects that are induced by ecstasy use, including mood changes and thermoregulation and autonomic nervous system dysfunction. Next is trifluoromethylphenylpiperazine. Trifluoromethylphenylpiperazine, or TFMPP, is a 1-aryl piperazine and known widely as a new group of designer drugs and are used as recreational drugs for their stimulant effects. TFMPP are members of the piperazine group of chemically synthesized compounds, along with other well-known compounds such as cyclizine and sildenafil. TFMPP is typically obtained in the form of a powder, tablets, or capsules. The primary route of administration is oral consumption. However, the powder is also being snorted or smoked. Next is alpha-methylfentanyl. Alpha-methylfentanyl, also known as China White, is an opioid analgesic that is an analog of fentanyl. Next is mecloqualone. Mecloqualone, nubrarine, or casfen, is a quinazolinone class GABAergic and is an analog of methaqualone that was first manufactured in 1960. It has sedative, hypnotic, and anxiolytic properties caused by its agonist activity at the beta subtype of the GABA-A receptor. It was used for the treatment of insomnia. Mecloqualone is faster acting but shorter lasting than methaqualone and so was used only as a sleeping pill, in contrast to methaqualone, which was used as a general purpose anxiolytic as well. Methaqualone was never as widely used as methaqualone and is no longer prescribed because of concerns about its potential for abuse and overdose. It is most often seen these days as a component in purported coagulotes, resulting from unfinished synthesis of methaqualone from concealed labs. Next is nitromethaqualone. Nitromethaqualone is an analog of methaqualone that has similar sedative and hypnotic properties. It is significantly more potent compared to the parent compound. Next is phencyclidine. Phencyclidine, PCP, also known as angel dust, crystal, killer weed, was synthesized in the early 1900s and tested during World War I as a surgical anesthetic. PCP is an antagonist of the N-methyl-D-aspartate, NMDA, inotropic receptor in the central nervous system, causing an inhibition of depolarization of neurons and subsequent interferences with cognitive and other functions of the brain. The natural agonist for this receptor is glutamate, which is believed to be a major excitatory neurotransmitter in the brain. In its pure form, PCP is a white crystalline powder that readily dissolves in water. Next is mescaline. Mescaline occurs naturally in three major species of cacti: peyote, Lophophora villemaceae, Peruvian torch cactus, that is Echinopsis peruviana, and San Pedro cactus, that is Echinopsis pachanoi. The drug was first isolated and identified in 1897 by German scientist Arthur Hefter, who performed for the first time a controlled mescaline self-administration. The drug was subsequently synthesized in the early 1900s. Similarly to LSD, psilocin, or tryptamines, mescaline acts through a G protein coupled type 5-HT receptor, specifically the 5-HT2A receptor. The drug causes hallucinations, euphoria, and many other symptoms. The pharmacologically active dose of pure mescaline in humans is 300 to 500 mg. Next is forensic analysis of designer drugs. First is Marquis reagent test. Preparation of reagent for methamphetamine and 3,4-methylenedioxymethamphetamine, that is MDA. 8 to 10 drops of 40% formaldehyde solution is added to 10 ml of concentrated sulfuric acid. For mescaline, solution A, add 8 to 18 drops of 40% formaldehyde solution to 10 ml of glacial acetic acid, and solution B, concentrated sulfuric acid. Now the procedure. For methamphetamine, appropriate amount of the exhibit is taken on a spot plate and added not more than 3 drops of reagent dropwise. Appearance of orange color turning to brown indicates the positive test for the presence of amphetamine or methamphetamine. For methylenedioxymethamphetamine, that is MDA, adequate amount of the exhibit is taken on a spot plate and added the reagent dropwise. Transformation of brown color to black and then to purple indicates the presence of MDA. And for mescaline, appropriate amount of the suspected material or exhibit is taken on a spot plate and add to it 1 drop of solution A followed by 2 drops of solution B. The appearance of orange to orange-red color indicates the presence of mescaline. Second is Simon's reagent test. First, the preparation of reagents. Solution A is 20% aqueous sodium carbonate solution. Solution B is 50% ethanolic acetaldehyde solution, and solution C is 1% aqueous sodium nitroprusside solution. Procedure. Appropriate amount of sample is taken on spot plate and added to it a drop of solution A followed by 1 drop of solution B and further few drops of solution C. Appearance of blue color indicates the positive test for the presence of methamphetamine, while appearance of slow pink to cherry red color indicates the presence of amphetamine. Next is Mendelin's reagent test. Preparation of reagent. 1 gram ammonium vanadate is dissolved in 100 ml concentrated sulfuric acid. Procedure. For amphetamines, appropriate amount of aqueous solution of suspected exhibit is taken and added few drops of Mendelin's reagent. Appearance of green color which darkens rapidly indicates the positive test for the presence of amphetamines. On stirring, the color passes through several shades of emerald green and dark reddish brown, which changes to light red-brown on heating. For methylenedioxymethamphetamine, that is MDA, appropriate amount of aqueous solution of suspected exhibit is taken and to it add few drops of Mendelin's reagent. Transformation of purple color to brown color gives the positive indication of MDA. Next is Cobalt Thiocyanate test. Preparation of reagents. Solution A, 16% hydrochloric acid solution. Solution B is 2.5 grams of cobalt 2 thiocyanate in 100 ml of water. Procedure. Small amount of suspected material is taken into a test tube. Add 1 drop of solution A and 1 drop of solution B. Blue color indicates a positive test for the presence of methaqualone or macloqualone. Next is Fisher-Morris test. Preparation of reagent. Solution A, concentrated formic acid, which is 88%. Solution B, 5% aqueous sodium nitrite solution. Procedure. Appropriate amount of suspected material is placed into test tube. Add 7 drops of solution A and 5 drops of solution B. Allow it to stand for 1 to 2 minutes. Then add 15 to 20 drops of chloroform. Shake well and allow it to stand. Observe the color of both layers. In water layer, methaqualone and macloqualone do not give any color while they give yellow color in the chloroform layer. Next is Mackay's reagent test. First is the preparation of reagent. 0.25 gram of selenious acid is dissolved in 25 ml of concentrated sulfuric acid. Procedure. Take appropriate amount of the suspected material or exhibit on a spot plate. Add to it few drops of Mackay's reagent. The appearance of orange color changes to brown color indicates the presence of mescaline. The transformation of green color to blue and further to purple indicates the presence of methylenedioxymethamphetamine, that is MDA. Next is Froday's reagent test. Preparation of reagent. 50 milligrams of molybdic acid or sodium molybdate is dissolved in 10 ml of hot concentrated sulfuric acid. The resulting solution should be colorless. Procedure. Take appropriate amount of the suspected material or exhibit on a spot plate. Add to it few drops of Froday's reagent. The appearance of brown color indicates the presence of mescaline. The conversion of brown color to purple indicates the presence of methylenedioxymethamphetamine, that is MDA. Next is Lieberman's test. Preparation of reagent. 5 gram of sodium nitrate added to 50 ml of sulfuric acid with cooling and swirling to absorb the brown fumes. Procedure. Take appropriate amount of the suspected material or exhibit on a spot plate. Add to it 2 to 3 drops of Lieberman's reagent. Occasionally, it is required to carry out the test in a test tube and heat it in a water bath at 100 degrees Celsius. The appearance of black color indicates the presence of mescaline. We'll end this module with summary. Designer drugs are congeners of active compounds that have been modified from legitimate pharmaceutical agents and are used for recreational purposes. Designer drugs are usually stronger and cheaper than the parent compound and can be easily synthesized in clandestine laboratories. The term designer drug does not include new forms or new dosing routes of old drugs. Example, cocaine used in free base form, that is crack. It also does not include legal drugs which are abused. Example, ephedrine, caffeine, phenylpropanolamine, etc. Spice and K2 especially, as they are widely used by high school and college students, are emerging public health challenges. Their rapid rise in popularity ready access from multiple sources, production of acute psychological distress, toxicity and potentially long-term harmful effects, ability to evade standard drug tests require an integrated national response. Not all cathinones are the same, with each deliberating a different set of health risks. Nonetheless, use of cathinone analogues is increasing rapidly, especially among youth and in the face of mounting evidence that they engender unacceptable risks and adverse consequences. Globally, of the various substances abused, alcohol and tobacco head the list, followed by sedatives and tranquilizers, cannabis, opiates and cocaine. Amphetamines and hallucinogens are less popular, though newer recreational drugs, that is designer drugs, are increasingly being abused, especially by the youth. Designer drugs have become increasingly popular among adolescents and college students as a recreational drug to be used during rave parties.